Welcome back. Today we're going to talk about scatter plots. And we've talked about this before, but we're going to delve into them a little bit deeper this time. And we're going to talk about not only making scatter plots, but the next section is how to create lines that fit the scatter plots. Okay, so let's just review about how to make a scatter plot. This is data that's been collected about hours spent studying and test grade. And we might wonder if there's some sort of relationship between hours spent studying for a test and the grade that someone achieves on the test. So the first thing that I do in order to see what this looks like is I plot it on a graph. Now, scatter plots are part of a field of mathematics called statistics, and statistics is actually a joint field between mathematics and science. And we say that because it's kind of more like a science because the data that we collect is based on observation, which is what we consider a science, right? It's not just known theory. It's based on observation and asking questions like, if we spend more time studying, do we get a higher test grade? Now, because it's a science and it's based on observation, you will recall this conversation that we've had before about the data is not always going to be as precise as it would be if we just used an equation to collect data or to generate values, to generate y values given an x value. But that's why we end up making things like scatter plots, and the lines might be sort of distributed about the graph in a certain way, and it might that all the points that we see are not going to fall along a straight line, because this again is more like a science where the data that's been collected is not as precise as it would be if it were just like in theory or in our minds. Okay, so let's go ahead and make this. So we have 0, 75. So at 0 we have this plot 75. Then at half an hour we have a grade of 30. And what I actually should have done is I should have taken a second and looked at the graph. So let's just stop for a minute. So along the x-axis we have hours spent studying, and along the y-axis we have test grade. Always make sure that they're arranged in the table the way you think they should be, which is that the left column would be the x coordinate and the right column would be the y coordinate, because every once in a while they'll switch those two around. You can just check that by the labels on the graph that they give you. Okay. Also notice that the x-axis is increasing by 30 minutes or half an hour for each little dash line, where the y-axis is increasing by 5s. And actually this is an incorrect value here. This actually should have been a break right here, and then indication that this is 55. Breaking so that you understand that we're not starting at the origin right here, that this value right here is 50. So it should have had that little jagged line that indicated a break. It's a little sloppy right here. But this goes up by 5s, and so it's indicated by having 60 and then 72 dashes away, and so on. Okay, let's get back to plotting our points. We have 1 and we have 80. So someone who studied for an hour got a test grade of 80. Another person who studied for an hour had a test grade of 85. And then 1.5 and 85 right here. And 1.5 and 95. So 1.5 and 95. So you can see already that there's different results of studying. For two different students have different results, each having studied 1.5 hours. One gets an 85 on the exam, one gets a 95 on the exam. So for 2, we have 90. For 3, we have 100. And for 4, we have 90. Okay, so this is what a scatter plot is. The points end up being scattered across the graph. The other thing about this graph is it's only in quadrant 1, which makes sense because the hours spent studying is going to be positive and the test grade is going to be positive. Very often when we have scatter plots, you generally see just quadrant 1. Every once in a while you might see quadrant 1 and 2 or quadrants 1 and 4. Like we've seen that before when we had a diver diving down below the surface, and we had quadrants 1 and 2 or 1 and 4, but very likely that it's only going to be quadrant 1. Okay, so this is how we reviewed how to make a scatter plot. Now the next thing that we're going to talk about, and by the way, we've made scatter plots before, but what we are going to bring in this lesson is the discussion of clusters and outliers. So a cluster is a set of closely grouped data. Data may cluster around a point or around a line. An outlier is a data point that is very different from the rest of the data set. Okay? So let's say that we have another situation here. A scientist gathers information about the eruptions of Old Faithful, which is a geyser in Yellowstone National Park. It's hot water that's coming out from a hole in the ground. It's like a porthole. The data shows the length of time during eruptions, the interval of time, and how often the eruptions last. So for instance, if I took a data point like this data point right here, this is about, let's see, this would be 70, so this would be about 78, comma, and about 4.9. Okay, so how would we interpret that? That point would be, let's see, the length of time, so this is 78 minutes. It erupted for a duration of 49 seconds, okay, and 4.9 minutes. So for an interval between the last eruption and the this eruption that we're talking about, it was 78 minutes since the last eruption had occurred, and it erupted for a period of 4.9 minutes. Okay, so that's important to understand. All right, so we're going to interpret clusters, and we're going to identify clusters and outliers. So first of all, this point right here is considered an outlier. Okay, it's away from the clustering of data, and these two packs of data right here are considered clusters. Okay, so you can see they're sort of grouped together, and you can sort of draw a circle around them. Now the circle doesn't include this little point right here, which is an outlier. Now it isn't necessarily the case that all data is going to have, or all scatter plots are going to have outliers and clusters. It may be the case that there are no clusters and there are just outliers. Or that everything's clustered together and there are no outliers. And we're going to look at the situations like that in the work that we do in this section. Okay, the last thing that we're going to talk about in the video today is determining association. So let's look at three different scatter plots. This scatter plot, it looks like the points are clustered along a line. Okay, because remember, a cluster can be either around a point. So these seemed like they're clustered around a point, like that would maybe be in the center here. Like it seems like they're all clustered around a center point here, and this seems to be clustered around a point like right here. But the data in these pictures are clustered around a line. So they look like they're clustered around a line that would go like this. Okay, and this point may be considered an outlier, but it sort of is not an outlier because it's actually clustered around this line. If I had another point right here, this point would be considered an outlier. All right. So the points that we see right here, they appear to be clustered around a line, and they also appear to be clustered around a line with a slope that's positive. Okay. When this is the case, we say that this is a positive association, meaning as the x increases, as the x variable increases, the y variable also increases. So for instance, if we looked at these data points, that would mean as the interval increases, the duration of time, as the interval between eruptions increase, the duration of time that Old Faithful erupts also increases. And that would make sense if you were talking about a geyser, because if it hadn't exploded in a while, then it's going to erupt with a lot more force and with a lot more water, and the duration of time will be increased because there's just all that water that's building up underneath the surface. Okay. If you have a scatter plot and the lines appear to be clustered around or the points appear to be clustered around a line that has a slope that's negative, we call that a negative association. And this would mean that as the x values increase, the y values decrease. Okay, so in this case, as one variable goes up, the other one goes down. So they work in inverse relationship with each other. All right. Now, and remember, this is what I talked about when I said that you might have data that doesn't appear to be clustered around anything, right? The data that we saw before, these two clusters were around a point that appears to be about the center. The two pictures we saw here, the data appears to be clustered around lines. Now here, the points don't appear to be clustered around anything, a line or a point. So we would say that this has no association, meaning the variables that we're measuring here. Now, of course, these pictures don't actually have variables. They don't have things that we're measuring on the X and Y. We're just using these pictures as examples of scatter plots that would show positive association, negative association, no association. But if you had no association, what that would mean is that the X and Y variables have no relationship with each other. That sometimes as X goes up, Y goes up, and at other times as X goes up, Y goes down, right? So we would say that there's no association here, right? We can also say that with positive association, sometimes the vocabulary that you hear is that it's trending upward, whereas negative association, we sometimes say that it's trending downward, like the trend or the relationship is that the line is going down. Okay, and that's the end of the lesson for today.